Hey guys, today we're going to be solving one-step equations. Now, we've solved equations before. I know you solved them in the last couple years, and I do a step that's a little weirder that I require of you to show in your work, and that's because I'm a big picture teacher. And so it's going to look like it's more than one step. So we're going to think of these more as one operation equations, because then we're just simplifying that one operation down. Okay, so the reason I have us do it, I need us to know, why am I picking this operation? What do I need to do in order to make sure that I know what number I'm picking, what operation I'm using to get rid of it, and why? So because of that, that's why we're going to see a little extra step in here. So let me know if you have any questions. So our goals for today are to solve by adding, subtracting, multiplying, and dividing. So these steps within our process are going to help us go through and learn, what do I do next? What do I need to do first? Why did I pick this number? Why did I pick this operation? Okay, so make sure your notes, when you're taking notes on this lesson, look identical to how I write the equations on the board and the steps, because that is what I'm expecting in your homework for you to receive credit. So our first new vocabulary phrase is to solve an equation, and it's the process of finding all the values of a variable that make the equation true. Now, there can be more than one solution sometimes that makes the equation true, but we won't see that for a few more lessons. So today, all of our equations will have exactly one solution and exactly one answer. With that, an equivalent equation is one that has the exact same solution. We use equivalent equations to go through these processes to find them. Today is to find the value of the variable that makes this equation true. And that's going to be the solution to this equation. Okay. And then, as we mentioned previously, equivalent equations have the same solution. And to solve them, the operations we'll use are called inverse operations. And they're operations that undo each other. So let's talk about those for a minute. So inverse operations, some of the operations we already know are addition, subtraction, multiplication, and division. The only two from our order of operations that are not up here are the parentheses and exponents. Exponents, we won't learn how to undo them until in Algebra 2. And then parentheses have their own set of rules that we'll actually see in a week or so. Okay, so with the addition and subtraction, which two out of these operations, which ones actually interact together? So if I add 2, how do I get back to that original number? Well, I would subtract 2. And so addition and subtraction are inverse operations. If I see addition, I need subtraction. If I see subtraction, I need addition. And we'll use those together. And so multiplication, if I multiply by 2 to get rid of that number, I should divide by 2. So that go together hand in hand, and that's why you learn them together. So you first learn about addition, and then after you used addition for a little while, you learned how to subtract. After you learned how to multiply, down the road a little while, you learned how to divide, because they go hand in hand together. So these are the operations we'll be using today as we go through these problems. So the idea for how we're going to solve these are using properties of equality. So we'll also see these for multiplication and division in a minute. So we're going to start with addition and subtraction. And so with addition, think about the scale when you're trying to balance two things on a scale, okay? So like the scales of justice that you've seen. So if you add something to one side, you have to add it to the other side to keep it balanced and keep it equal. So if you don't do that, it's not equal and it causes a lot of problems for us. Then with subtraction, if you subtract on one side, you then have to take it away from the other side as well to make sure you remain in equal balance and you didn't change its value. So we're going to be using these two pieces to help us out as we go through and we learn how to solve some of these other parts. So here is where you're going to see where Miss Casebeard differs from a lot of other math teachers with how I make you show work. Okay, so to start off with, I want to solve for h. I want to get h all by itself. So, to do that, let me erase that, because that will drive me crazy. So, in order to do that, what we're going to do is I need to get rid of this minus 12 that's here. So I see subtraction. Take a moment and think through, what is subtraction's inverse operation? It's addition. So because of that, I'm going to write my plus 12 underneath my minus 12. I'm going to bring the arrow down for the equal sign. My equal signs now have to be lined up. So the initial question, the middle steps, and the answer, all of my equal signs have to be grouped together in order for us to go through and solve these pieces. Okay, so I added 12 on one side, which means that balance scale says I have to add 12 to the other side as well. Okay, so I have different signs on the negative 27 and the positive 12, so I'll subtract them and keep the sign of the bigger number. 27 is bigger than 12, so I'll keep a negative with my value. So 7 minus 2 is 5. And then 2 minus 1 is 1. So my right-hand side of my equation equals negative 15. So far, this doesn't look any different than what your previous teachers have made you do. The left side is where I'm a little different. Okay, so h doesn't have any like terms on the left side, so I'm going to keep the h. And now, think about, what is negative 12 plus 12? What's that value? Oh, it's 0. So because of that, I'm going to add a plus 0. I need to see this plus 0. So think about to our properties that we just had on our last test. What property has me add two numbers to get to 0? It's our additive inverse. And so we're using our properties to do this step, but it's also helping us understand, why did I pick add 12? Why did I choose this? Because if it didn't go to 0, that's a problem for us. We haven't solved anything. And so with that, we're using this for when things get crazy later this year, to where it just feels like one or two more steps versus feeling like I flung you off on the deep end and it's really crazy hard. Okay? We want the hard things not to necessarily not be a challenge, but we want them not to feel like we don't know where to start. Okay? So we're going to start with basics, which will help us through as things add on and get more technical and difficult. So in this problem, now h plus 0 is just h, and that is our additive identity property from our last chapter, and that will equal negative 15. And that is my final answer. You do need to take the time to write out your final answer without the plus 0 in it, but I do require to see that plus 0 step inside of your work. So remember, things your homework should look like: equal signs lined up together, okay, including my answer equal sign. And then I need to have that plus 0 step if I am adding or subtracting. So let's go do another one. Okay. So in this problem, the variable I want to solve for is c. So I want c to stay put, and I want to move that 102 away from it. So in order to do that, I see that I have added 102. Who was addition's inverse operation? Oh, it's subtraction. So let's subtract 102 from both sides of the equal sign. So I'm going to draw down my equal sign so I know where it's going, because then they're lined up. And I'm going to subtract 102 from both sides. I'm going to write subtraction on both so I remember that subtraction. Okay. So the new side, that's a little weird because it's one of my things, is on the left-hand side. C doesn't add with anything, so it just stays C. And then positive 102 minus 102 is 0. So a plus 0 goes here. Okay. Then in my next column, my other side of the equation, I have 36 minus 102. They have different signs, so I do need to subtract. And so with that, when I go to subtract them, we get, I'm going to go off on the side and subtract. But my final answer should be negative because 102 is negative. So right now I can't subtract 2 from 6 because I have a double digit. Now instead I can borrow from the 10 and make that a 9. And then 2 can become a 12. So 12 minus 6 is 6. 9 minus 3 is also a 6. So my final value on my right side is negative 66. So what is c plus 0? It's just c. and that equals negative 66. And that's how we ended up solving this one. Please make sure to take a minute and take all the notes because you are still required to have notes from this video. So let's go do some more problems. So at this point, I would like you to go try both of these problems, okay? So I'm going to ask that the video gets paused, try them, and then play to get the solutions. So I'm not going to walk us through the steps for these because I want you to try them on your own right quick. So go ahead and pause the video. Now, check your solutions right quick. If you'll notice the second one where I solved for B, I didn't rearrange the equation. You don't have to. I am okay with B being on the right-hand side. If that bothers you, though, you can rewrite that as B equals negative 4, and that means the exact same thing. I'm happy with either answer. Just make sure you rearrange properly if you're going to rearrange. Okay, so let's go do 2 more problems. So let's solve this first one together, and then I'll let you pause and do the second one. So on this one, I do see that negative 5 plus x. So I see addition. So my instinct is first, I need to subtract. But if I subtract 5, what's 5 minus 5? That's negative 10. That's not 0. So that didn't help me solve it. So instead, I need to think negative 5. I need to get to 0. What number do I add to negative 5 to get to 0? Well, if I use my additive inverse, that tells me I need to add the opposite sign. So negative 5 plus 5. So adding 5 to both sides and bringing down my equal sign. Well, negative 5 plus 5, that is 0 plus x. And 6 plus 5 is 11. So 0 plus x is x. And that did let me go through and solve for this one. So I do have to be careful with signs. The sign in front goes to the number with it. The sign behind it goes to the next value. So over here, if I'm looking at this 6 is positive, and so is w. So in this situation over here, I still subtract I still subtract 6 because 6 was positive. So to change it, I need to subtract it. So with that, on my left-hand side, where I see that w, okay, I am left with just 0 plus w. Bear with my handwriting today, guys. It's not the greatest on the computer. And then negative 18 minus 6. Well, they have the same sign. They're both negative. So I'm going to keep the negative sign, but 18 plus 6 is 24. So I'll have a negative 24. So then 0 plus w is w. I get a negative 24. And that is my answer for that particular problem. Talk about multiplication and division. So in order to multiply, if I do it to one side, I have to do it to the other side to keep it balanced using that property of equality. With division, if I divide one side, I have to divide the other side to keep that property of equality. So we do want to be very careful with that. Okay, so let's go do another problem. This first problem, I see I'm dividing by 6. Because I'm dividing by 6, my inverse operation should be multiplying. Well, if I'm dividing by 6, then I need to multiply by 6. So let's multiply both sides by 6. So the easy side, 5 times 6 is 30. Okay, but on this other side, I have a whole number times a fraction. Now, some of you are going to be able to go ahead and go simplify at this stage. Some of us have a really hard time. So in the PowerPoint, in this video, I'm going to show us the long way. So if I put 6 over 1, I now have a fraction times a fraction, and I know how to do that. So 6 times n is 6n, and my denominator, 1 times 6, is 6. Okay, so my multiplication has a weird step, just like my addition and subtraction did. Multiplication and division have the same step. So what's 6 divided by 6? that's 1. So with multiplication division, you have to show me how did I get to this 1 times n. And so just to connect it with things we talked about earlier, so using the reciprocal of 1 over 6, I use 6 over 1, which is the multiplicative inverse. And so that multiplicative identity is 1, which was what my goal was. So the step I have to see, and I'm going to highlight it here on the screen so you can see it, I need to see this step, even if you simplified a little bit earlier than I chose to. Okay, so now 1 times n is n, and that equals 30. So this problem is done. Okay, so in the next one, I see I have negative a over 5 equals negative 20. Let's move that negative to be with the 5 in the denominator, because I can't leave the negative, and so I have to get rid of it. Okay, so I have divide by negative 5, so I should multiply by negative 5 to get rid of it. So negative 5 over 1 and negative 5. Use parentheses, use parentheses, use parentheses. A number of you put a dot on your test and it blended in, and somehow multiplication became subtraction. Do not do it. Just use the parentheses. Please, I beg of you. So on the right-hand side, negative 5 times negative 20 will give me a positive number, and 5 times 20 is 100. So I have positive 100 on my right-hand side. And then on my left-hand side, I have negative 5a over negative 5, because negative 5 times a is negative 5a. 1 times negative 5 is negative 5. Well, negative 5 divided by negative 5 is 1. I multiply that by my a, and that equals 100. Not done yet. Using my multiplicative identity, 1 times a is a, which equals 100. And that is my answer for that one. And that is an A, not a 0. Okay? So let's go do 2 more problems. On this first one, I see 3 times a. So if I have multiplication, I need to use division as its inverse operation to make it go away. So if I divide both sides by 3, and bring down my equal sign, 12 divided by 3 is the easy side that you're used to. So on the other side, what's 3 divided by 3? That's 1. So I'll have 1 times a, and 1 times a is a equals 4. So on this, or when I use division, wrong piece. We need to see this, what am I doing? Okay, it's been a long day, guys. So first, let me erase those 2 horrible lines I did. Oh, they went away easy. Awesome. Okay, so this is the line I expect to see, because I need to see the multiplication by 1. So let's go try another problem. Okay, so negative 8 equals 5y. I see multiplication between 5 and y, so that means I need to use division by 5. So I have 5 divided by 5 is 1, multiply it by my y, negative 8 over 5. So do negative 8 and 5 share any similar factors? No, they don't. So because of that, I can't simplify that side anymore. So I'm going to keep 1 times y is y, and then I'm going to keep my negative 8 over 5 fraction, and we're going to combine it together. Oh, I never boxed my other answer over here of my a equals 4. That's a bad 4. So it's okay to have fractions as your answers. It's okay to have decimals as your answers. Okay, we use them all the time in Algebra 1, so we will see them quite often. Okay, so we have one more type we need to see and a word problem. Then you're done with examples in the video, and you'll have time to sit down and work on your homework assignment. Well, this multiplication looks different than the other ones that we've had. So if we think about that we're using these inverse operations, the multiplicative inverse is using the reciprocal to make the number go away. So how about we multiply by negative 1/4 reciprocal on both sides to help make it go away? So what is the reciprocal of negative 1/4? That's right, it should be negative 4 over 1. So 8 times negative 4 is negative 32. 1 times 1 is 1. So my right-hand side is going to equal negative 32. Okay, well, on my left-hand side, negative 4 times negative 1 is positive 4. 1 times 4 is 4, and I keep the m. 4 divided by 4 is 1 times m, and so m equals negative 32. So using that reciprocal allowed me to get down to that multiply by 1 step that I'm requiring of you, and then it ended up showing me my answer pretty directly. Okay, so let's do the next one. Well, I have to decide what is my reciprocal of the fraction that is present. And so my reciprocal of 2 over 5 is what I'm worried about. And so I'll multiply that on both sides. 8 over 15. So my reciprocal of 2 over 5 is 5 over 2. Now, the 5 over 2 over here is the new fraction. I need to use the new fraction on the other side, not the one I started with, because I need to add the same, I need to multiply the same thing on both sides that's new. So on my left-hand side, 2 times 5 is 10, 5 times 2 is 10, and my a can hang out. And then 10 divided by 10 is 1 times a, and 1 times a is a. Okay, now on the other side, 5 times 8 is, that's right, it's 40. That did not look like a 40. Let's try that 0 again. So 5 times 40, not 5 times 40, 5 times 8 is 40. And then 2 times 15 is 30. Now, unlike the last fraction we had at the very end, can this one simplify? Yes, and that's because 40 and 30 share a common factor of 10. So 40 divided by 10 is 4. 30 divided by 10 is 3. So a equals 4/3. Okay, so this is our last problem and example today, and then you'll have some homework time. So a mom holds her baby and steps on a scale and weighs 147 pounds. Alone, the mother weighs 129 pounds. How much does the baby weigh? Now remember, we're in the section where we need to write equations to solve. I know some of you can already tell me the answer to this one, okay? But we need to make sure we have the math that goes with us to help us out. So, first thing I need to know, they tell me, hey, I want to know how much does the baby weigh. So that's what I don't know. So that's what needs to be my variable. So I'm going to pick B for the baby's weight. Remember, you have to give me your key in order for it to work. Okay? So both sides of this equation should equal the total weight. So I know one total weight. It's the amount that the mom and the baby weigh when they're standing on the scale together. So that's 147. How can I write, hey, this is the total amount together on the other side of the equation? Well, if the mom weighs 129 pounds and the baby weighs B, if I add them together, that allows me to get my total. So all of the word problems you'll do tonight should have one step only, one operation. You should only see addition or subtraction or multiplication or division. You should not have two of those, to where these should be some simple ones to solve. We'll get into those multi-step later, okay? So if I subtract 129 from both sides to solve, because 129 is positive and I need to go to 0. So that gives me 0 plus b, which equals, well, I can't take 7 from 9, so that becomes a 17, and I borrow it from the 4, who becomes a 3. 17 minus 9 is 8. 3 minus 2 is 1. 1 minus 1 is 0. So b equals 18. Now, don't forget, you have to give me your final answer in context of the word problems. So I'm going to write at the top because I've kind of run out of space. So my final answer is the baby weighs 18 pounds. And then don't forget to box your answer. With word problems, you do have to give me your answer within the context of the problem. By writing our key, you made that a little bit easier for yourself because it'll help you figure out what's that variable equal to. Oh, it's the baby's weight. Okay, so now you're going to have time to work on your worksheet. Make sure you are working down the column. Your equal signs are equal on your lined up on your paper. Okay, your equal signs should not be side by side. That's a problem with equations. Okay, and so hopefully you took notes so you have a good example of what your work should look like tonight. Okay, if you're not sure, go and see your substitute and they can verify because I left them with a few examples as well. Okay, have a great day, guys. I will talk to y'all later.